Hello everyone and welcome to the how-to series of webinars from HMS Networks. I'm Bill Killick of HMS Sales and with me is Fredrik Brynolf of HMS Sweden Product Management. Are you there, Fredrik? I think he's there. I think he's just on mute. I hope so. He'll be joining us later. Today we're going to be looking at one of the most fundamental things you can do to work smarter in the field of digitalization. It's quite often one of the easiest. It brings massive returns on your efforts really quickly, and is one of the reasons why HMS has so many happy customers. It could save you lots of money, lots of time, and help you to stay ahead of the competition. And if you haven't already done it, you might want to after this presentation. Today, we will be looking at how to get a non-networked machine onto a network and why you should do it. So a quick word about the presentation. You should be able to see my face or Fredrik's or the slides, but there won't be a control for the microphone or the camera because that's automatically shut off. So there's no chance of accidentally being on camera, but you should see a question bar on the side of your screen, and you're very welcome to submit questions or comments as we go along. We'll try to answer them at the time. If not, there'll be time at the end of the presentation for questions. The whole thing should be about half an hour. And once we've finished, we'll send you a link to the recording and you can watch it again and send it to colleagues. Connectivity is at the heart of everything we do at HMS. HMS stands for hardware meets software. And all over the world, we're helping to connect people to data, data to machines, machines to machines, and people to machines. Not in a Borg way, but just in a way that enables just valuable insight and helps people to work smarter and hopefully have a better work-life balance. And we have four main product brands. With Anybus, it's really about connecting machine to machine. So protocol gateways, for instance, if you have two major networks of machines and you need to connect them together, but it's also wireless product. So an automated guided vehicle, or even a building to building connection, or a crane, some kind of moving vehicle where you need to have some sort of wireless connection. E1 is really about connecting people with data. So remote access, dashboards, alarms, data logging, those sort of things, which is obviously all the rage at the moment. Intersys is about connecting smart buildings. So we have an app, we have cloud, we have protocols, gateways like KNX and DALI and other things that are loosely associated with air conditioning and HVAC and other things like that for smart buildings. And ICSAT is making machines work on the inside. So CAN, FlexRay and other auto testing, smart grids, functional safety systems. As well as those, HMS is always on the lookout for technologies or companies that can help it expand its offering to the customer, especially with IoT. And it has recently acquired two companies, Web Factory, who provide an online SCADA system, and Procentec, who deliver network diagnostics, so you can maximize your uptime on your critical networks. And we work with a whole load of technologies. We've sold over 9 million products. We have operations in 16 countries and lots of supply outlets, centers of excellence, manufacturing all over the world. And just to give you an idea of one of the reasons why we're so in tune with our customers' requirements is 40% of our staff are involved in R&D. I've got a question for you. Would you like to spend 7,000 of your local currency and do lots of work, or 500 and do less work? Just wondering if there are any questions. I'm going to open my question bar for that to see if there's any comments. I'm guessing really you don't want to spend anything, but if you had to overcome a problem and you needed to do something, you'd rather spend less money and do less work as long as you got the same result, right? Okay, well, we'll come back to that later. So how to get a non-network machine onto a network and why? And what do we mean by non-network machine anyway? Before we go any further, I want to explain what an industrial protocol is, and I'm going to use the example of my two children. They're not actually here. I'm not going to take that risk. I just want you to imagine. Now, they both speak English. They're 8 and 6, by the way. They both speak English quite well, but my younger one doesn't know how to use it. He doesn't know when to use it based on the situation. So if I'm talking to someone already, or for instance, if I'm on a webinar, he will just come up and talk to me, and he'll just keep talking until he gets some sort of answer. And it makes it quite difficult because you can't really do everything all at the same time. And that is a protocol. And humans use it for all sorts of things, and so do machines. And if you think about different situations that you've been in, a restaurant, remember those? Or a classroom, or a medical theatre, or all sorts of different applications, you will use your language in a different way because of the situation, and that's a protocol. And in the same way, machines use different protocols for different things. So, for instance, maybe a medical protocol might need to be very accurate, whereas a mass production might need to be quick. So that's why there are a lot of protocols. And the important thing is, every machine on the network needs to talk the same protocol. So imagine you're a factory owner. You have a lovely shiny new factory with lots of machines that are all talking to each other, but you also have a weighing machine in the corner. And this weighing machine works perfectly well, but it doesn't talk the same protocol. And it can't talk to those machines like they need it to, a little bit like my son. And that's what we mean by a non-networked machine. Basically, when this machine was designed, nobody thought it would need to network with anything else. So as the factory owner, you really want to incorporate that in your system. When something gets weighed, you want maybe the conveyor speeds to change, or change the size of boxes, or print the label, print the weight on the label. But you can't integrate it. So you could buy a new machine. That means getting rid of your old one, spending money on your new one, making room for it, wiring it up, testing it, training everyone, writing the procedures, certifying it, doing all that work and expense. Or you can get a clever little box of tricks that sits between your existing machine and the network and solves your problem. And that is the Anybus Communicator. And this works for both makers and users. If you are a machine builder, you want to concentrate on your specialist subject. But when a customer comes to you and says, can it talk CC Link? You want to be able to say, yeah. Can it talk Profibus? Yeah. Can it talk EtherCAT? Yeah. Without having to truly understand all the details of those protocols. If you're a user, you want to be able to buy the best in class of any machine. You don't want to be limited by the protocol that you've already got. And again, that's where the Anybus Communicator comes in. So remember that question that I asked earlier? Well, we have lots of customers who have been faced with that precise question. In fact, those numbers are of an example of a customer who decided, instead of buying a whole load of new machines, they bought a communicator and integrated their existing machine into their network. So how do you actually do it? Well, I'm going to go over to Fredrik and see if he will take us through that. Fredrik, are you there?
Yes, Bill. Hi. I finally found the unmute button.
I was just going to ask you, actually, you're product manager for this line, aren't you? And your title is product manager OT. I was just going to ask you what the difference is. What is OT?
Yeah, OT stands for operational technology. So we have OT that's used on the shop floor, right. And we have IT that is used in the office.
Right. Okay. I understand.
All right. Let's talk about how you get connected. So let's say you find this beauty in the basement and realize it could be put to good use on your production line. But how do you get it connected? Well, bring out your inner Sherlock and follow this simple 5-step process. The first step is to find the communication port. Start to look for communication ports. Usually there's a serial or CAN port somewhere, or you may find something exotic like FIP.io, Loanworks, or even Interbus. Look for markings and similar clues. And if you have the scrolls, you should definitely roll them out to see if you can find any clues in there. The internet, of course, is an excellent resource if you're missing the manual. And once you know what you're dealing with, you've come a long way, and it's time to move on to step number 2. So, okay, it's more commonplace to have a machine like the weighing scale that we talked about before, but it didn't really fit our Sherlock theme, so we changed it. But okay, on to step number 2. So now you know how to physically connect the device. The next step is to understand the protocol the machine talks. Machines may use the same physical port, but talk different languages or protocols. And as we mentioned before, there are many ways to talk. Just think of it as different languages. If you know what language the machine talks, you can pair it with an appropriate gateway. There will be clues out there on the communication port or in the manual. Look out for Modbus RTU, serial ASCII, CAN, or similar. And you don't need to go deep, as our gateways support multiple protocol variants. Here are some additional things that can be good to know on step number 2. So most industrial communication protocols are based around the idea of a controller that's asking questions or giving orders, and a machine, device, or sensor that's responding to questions or executing orders. The one asking questions and giving orders is called a master, scanner, client, or similar, depending on the network. And the one responding and executing orders is called a slave, adapter, server, or similar. Another thing you should know is that there are different modes. There is the normal conversation where you have information that is exchanged in both directions. That's called request response. Sometimes there's also a producer mode. It's like someone talking without taking in any feedback. One good example is a hand scanner. You scan a barcode and it sends away a stream of data. Consume is the other way around, someone who is silently listening and taking in information. So now it's time to find your gateway. Just go to anybus.com, click on Gateways, and use our gateway selector. And before you go ahead and order, a good practice is to draw your topology so you understand the different roles you need the gateway to play. On one side of the gateway, you will have your PLC or control system. And on the other side, you will have your machine. The PLC will act as a master and send out questions and commands. And the machine will act as a slave and answer questions and/or take action based on the commands. In between, you will have the gateway, who will act as a translator. It will be a slave on the PLC side and a master towards the machine. So on anybus.com, you select the protocol in the drop-down boxes, and you select what role the gateway should play on each side. And once that's done, you are presented with an appropriate gateway. And then it's on to step number 4. So once you have received your gateway, it's time to get down to business and get the communication flowing. So this is done in a graphical user interface. No programming is needed. And we are behind you all the way. There are startup guides included with the gateway, There's a manual available on the product support page, and there are how-to videos that you can follow along. And here is one example of how you connect our new communicator. This is from the startup guide, and in this case, it's an Ethernet IP adapter on one side, or slave on one side, and a serial master on the other side. So first, you connect an Ethernet cable from the PLC, Ethernet IP network, to the gateway. And there are two ports that are clearly marked Ethernet IP on the front side of the gateway. So you see them even if the gateway is mounted in a cabinet close to other products. And two ports allow you to do daisy chaining and avoid additional costs for switches. And then you connect the serial cable by screwing it to the connector. And then you plug in the connector to the gateway. And this is when your knowledge of the port comes in handy. So you are able to connect the cables to the appropriate location. Some networks have standardized connectors, and some require you to screw in cables to connectors. And then you pull out the power connector, get it wired up. In this gateway, we support 12 to 32 volts. So your standard 24-volt outlet will work well. And next, you pick up an Ethernet cable and connect that to the gateway configuration port and then to your computer. So last but not least, open up your favorite web browser, enter the IP address of the gateway, and follow the instructions in the web-based user interface and do your configuration. And then it's on to step number 5, verify operations. So when you do your configuration, you can either do the entire configuration and verify if it works, or set up a part of the configuration and verify if it works. That's up to you. My recommendation would be to break it down into parts if it's a complex configuration. And to help you test your configuration, there are simulators available. We offer Profinet, Profibus, DeviceNet, and CanOpen Master simulators. And this allows you to test the gateway in a workbench environment before you put it into production. There are also free and paid simulators available for Modbus and Serial. That was the 5-step process. And if you want to know more about different applications, check out our application stories on anybus.com. And now I will hand it back over to Bill to summarize this presentation. Let's see if Bill remembers to unmute.
Right, there I am. So we've done one each, I think. I'm hoping you can see the slide of the application story. So it's 1-1 then, Fredrik. Just on that point there with this application story, we've been talking quite a lot about how to get information from a device into a network. But don't forget, you can do it the other way around as well. So we have an application example of a customer that does a lot of calculations and computations in on a sort of major protocol network, but then outputs that to big displays for railway stations and sporting events, and that's a serial device. So you can go either way, and we have lots of application stories of that on the website. So just 3 key takeaways then for today. I think the first thing I feel really passionately about this is the whole sort of digitalization journey starts with connecting everything, because then you get the benefits of all the different possibilities. And this communicator is what starts you on that journey. And it is a really simple process. You can keep, in a lot of cases, you can keep all the machines that you've already got and put them on the network. So it's really a minimum risk, and it works for makers and for users. All you have to do is identify your communications, identify your ports, identify your protocols, and then connect to your network. It's an easy config, it's an easy testing, and actually we didn't really mention, but there is a relatively easy process of scaling up, so of saving a configuration and then reusing it, and then that's it. I've put a couple of links on here to the website and to how you can contact us, and don't forget there are our emails on the front of the presentation as well. So I think we've got a little bit of time for questions. So if you should be seeing the question bar on the side of your screen. If you want to submit those, we'll pick those up. I've got one from John here about what's the difference between the blue communicator and the grey one. I'll take that one because it's an easier one. The blue one is the one that's been out for a long time. Lots of customers have been using that range, and it covers all the major industrial protocols, and on the other side the serial and CAN devices. And we've taken all the lessons that we've learned from that and applied some extra technology to produce what is effectively a new version. It's got some new features in it. It has slightly easier web browser based programming, but at the moment the range is quite new. So we will be gradually adding new grey versions in, which will at some point replace the blue ones. We're still going to be supporting the blue ones, but we'll be moving over. So I think we've got another question from Steve here, how easy it is to program the communicator. I'm going to pass that one over to Freddie, if that's okay. Fredrik, if that's okay, can you answer that? How easy is it to program the communicator?
Definitely, I would say it's pretty easy, especially the new one where we have a drag and drop based web configuration interface. So even if you have a complex proprietary serial protocol, you will drag and drop objects to build the communication frame that will be used, and you will graphically connect that to nodes. So we made it really easy, and we've done usability testing extensively to figure out how to make it easy.
Cool. And I think is that we don't have any. Oh, one from, is that Aggie? Can it only talk serial? Fredrik, do you want to answer that one?
Yes, it's a good question. Yeah, we have, for example, Modbus RTU. We have custom serial protocols, but we also have a CAN version of the communicator, and we also have a lot of different X gateways that can talk other protocols as well, both master and slave. So we have a comprehensive lineup of different gateways. Just go on to anybus.com, click on the drop-down boxes, and find your combination.
Yeah, that's a good point. Actually, we've been talking more about the sort of entry level, getting your non-network device onto a network, and of course HMS offer a whole range of products for once you are on a network, talking between networks, remote connection, all sorts of other things. So yeah, good point there. And in fact, some of our we've got just another question from Matt here. Do you see the communicator as being able to connect directly to IT systems for data capture via Kepware or similar, or do you see it as machine to machine? You've used one of the blue ones to connect serial Profibus with reasonable success. Oh, good. Well, I hope it's. I'd like to talk to you more about what the reasonable success is, but I think as it happens, Fredrik and I are doing another webinar in a couple of weeks about our .NET gateway, which is effectively breaking down that wall between the factory and the office. And I think that might be maybe more relevant to your question. Fredrik, do you want to say anything about that one as well?
Definitely. Yeah, we have an IoT version of the communicator as well, of the serial one, for simple applications. And we also have the Anybus Edge gateway for more advanced IoT applications. And then we have the .NET gateway that you just mentioned, Bill, for more advanced applications where you can integrate directly from a .NET-based PC application to an industrial network. Could be, for example, an order management system, or it could be also handling raw machine data, quickly doing on-the-fly analysis and corrections of the machine.
Okay, let me just double check here. I see we put a couple of bits of info in there, and hopefully, Matt, that is that will answer your question. But please feel free to contact us with the emails or the or on the contact form that we put in the presentation. I think that's it for the questions. So I'm going to wrap up there. We will put we'll make sure if we've missed any questions, we'll make sure that we answer them when we send the link to the recording. Like we mentioned before, there are a lot of other upcoming webinars. Matt, you might want to check out the .NET one and have a look on the website. There's lots of other ones as well. I'd just like to say thank you ever so much, Fredrik, and also Poppy in the background. And thank you to you guys for attending. And I think for now, that's it. Thank you very much and stay connected.